So I want to do another example where we have to factor out a GCF, and I want to do one that is, I should say, a little bit more complex than the first one we did, right? So the example I want to do this time is we have 22b squared minus 34b minus 20. So our first step here is to recognize that each of these guys is divisible by 2. So we have a greatest common factor that we can pull out. Now, one thing that I always do is I look back over my factor expression here and check and make sure that I didn't miss a greatest common factor. In this case, 2 is, in fact, our greatest common factor here, so we're okay. But if you don't get the right greatest common factor the first time around, you should be able to see that you have something here that you can continue to factor out. Okay? Now, our next step is to deal with this guy normally. We're going to take our 2 and we're going to set it aside. And what we really want to focus on is this. We want to focus on factoring this guy. So I'm going to start by multiplying 11 and 10 together, which is going to give us 110. And I want to start working through my factors. So I know I have 1 and 110. I got 2 and 55. 3 doesn't work. 4 isn't going to work. 5 will work. It's 5 and 22. And since this guy is minus, we're subtracting these guys. So I want a difference of 17. This is going to give me my difference of 17. So I'm looking at 5 and negative 22. Remember, your larger term, or I should say factor, is going to have the same sign as the middle. All right, we're going to break this guy up now. I've got 11b squared minus 22b plus 5b minus 10. And this time, I've switched the order of these guys to make it more fun to factor. That's just my personal preference. If you have it as plus 5b and minus 22b, it'll work out the same way. So in this case, I can factor out 11b, which will leave behind a b minus 2. In this case, I can factor out 5, which will leave behind a b minus 2. And so this will end up factoring into 11b plus 5 and b minus 2. But my final result has got to include that GCF that I factored out at the beginning. Now, let's look at what happens if we don't factor out that GCF and we just proceed with our factorization technique. So I would start off by multiplying 2 and 20 together, which would give me 440. And I'm looking for a pair of factors that are going to combine and give me 34. And again, we're subtracting. That hasn't changed. So I'm thinking about this, and I've got 2 and 220. That's going to have a difference of 218, which is way too big. 4 works, and 110, which is 106, which is still way too big. Okay. At 5 and 88, which will give me 83, which is still too big. I've got 8 and 5, which will give me a difference of 47, which is getting closer, but still too big. 9's not going to work. 10 will work, and that'll give me 44, and that gives me 34, which is what I want. So this guy's going to come down, this guy's going to split up, and this guy will come down. So we'll have 22b squared minus 44b plus 10b minus 20. Now, on our first two terms, we can factor out at 22b. And that will leave behind a b minus 2. On my second two terms, we can factor out a 10. And that'll leave behind a b minus 2. And when we go to write our result, we're going to have 22b plus 10 times b minus 2. Now, because we missed our greatest common factor at the beginning, when we look at this guy, we can see now that this has got a greatest common factor of 2. In order for us to get our answer right, we have to pull that greatest common factor out. So in this case, I'm going to factor out a 2 from this factor, and that's going to leave me with 2 times 11b plus 5 times b minus 2, which was our original answer.